This is a Tesla coil. I built it over the course of the last 2 years, and it took me so long because parts are expensive and I keep messing up. But I finished it, and it works. So here's a quick explanation of how it works. Through the orange wire, there is power from the house that goes into here. Big white box over there, that's a transformer. It steps up the voltage to around 12,000 volts. That charges this capacitor that's made out of glass and aluminum foil, and that happens every half cycle of the alternating current. So basically, 120 times per second, this capacitor charges. It sparks through this spark gap here, which is being quenched by this vacuum cleaner, and that just keeps the airflow going. With each spark, it runs a pulse of electric current through this big flat coil here, and that causes the coil to ring or resonate with electric current, which induces a flow of current in this tall secondary coil. As the current travels up the coil, it gets closer to the top and the voltage gets higher and higher, until eventually it collects on here, which is the top load. Anyway, that's how that works. And I have a ground rod here, and that's connected directly to the earth. And so is the primary circuit. That's my safety ground and radio frequency ground. So when I run it, it creates a large electromagnetic field, and if anyone has a pacemaker, or if there are like cans of gasoline nearby, it basically, well, it'll ruin pacemakers forever, and it can also cause sparks in metal containers, which can blow up cars, which is why those are in the street. So yeah, it's pretty dangerous, but also pretty cool, and I'm very proud of it, and it was well worth the time and effort. So, this is the Tesla coil. We're going to run it right now at dusk. It's had a good time to cool down, so there should be some good streamers coming off this breakout point right here. Ready? This is the Tesla coil running at night. We should have a good dark background to see the sparks on, and it's front lit with the garage lights. We took a take before and it didn't work because it was too dark. Alright, hit it. We just broke the fluorescent tube, and we're cleaning it up. You could see that towards the end of that last take, the length of the arcs got a lot shorter. That's because the capacitor down here, it definitely heats up because there's some corona that's happening on the inside, and I can fix that by filling the entire thing with oil, and that will reduce the corona. It does look a lot better in person though. The camera doesn't pick it up too well.